as well. But you provide. Oh, this was a really strong sausage. But if you were to get that kind of compute resources, you would be able to basically make a cloud that researchers outside of KB could get in and use the data in some way.
Yeah, for as of now, we have to prioritize our own models.
Yeah.
So it's the really big models that we build on KB data is it's KBLab who sort of govern that completely.
Yeah.
And it would be interesting to open up ways for others to use the data as well and to compete with us, I think, and sort of level the field a bit.
So you saw this call and you thought this could be, since you are providing basically a research infrastructure, that's what you want to do.
Yeah.
Right. And then you tried to apply, or what happened then when you?
Yeah, so we started to write the application, and we had a really good layup, and we started to work with the with the abstract and everything, and we had recruited a board for this, and with all the things that comes along with that, it should be a nice the composition of gender, etc. So and competences and everything. So everything was on a roll. And then we got the sort of signals from one or two of the suggested board members. Have you really talked to the National Research Council? We think that this might be the wrong call for you guys. So we contacted the council, and yes, we were sort of, no, only universities can apply for this. And it didn't say anywhere. So
couldn't you do that in tandem or in collaboration with some research or some university, you think? Or?
I think the stated sort of ambition from the Research Council, which was not stated in the call, is that there should be only one computational center in Sweden.
Really?
Yeah, at least for this call. So it should be centralized. And it should replace the old Swedish National Infrastructure for Computation, SNIC.
SNIC, yeah.
So they're sort of phasing out SNIC, and this should come instead.
So there was an agenda here that was quite, if you knew it, it was quite obvious.
Yes.
But you didn't know that bottom line agenda.
We didn't know it. And this sort of, I knew that it was a call for a national center as well. I just didn't understand that it was this call because it wasn't obvious from the call. So,
and it was also a bit more HPC focused then, or was it more AI focused, or?
The national call, it was HPC.
Yeah, because SNIC, is one, of course, and they have a number of machines both in KTH and Chalmers and Linköping, etc. Yeah. But was the idea to replace it or to amend to it or add to it?
Basically to build a second Berzelius pod.
Right, okay.
So, and when I look at the size of the call, as far as I can sort of appreciate that in terms of size, it was a pod of the same size as Berzelius, so kind of double that.
But Berzelius, for people that don't know, it's a big Wallenberg-funded cluster in Linköping, and it's still 60 DGX machine, like 480 AU100s, right?
Yeah, I think it's like something like that, yes.
Like 300 million.
So it's in a European perspective, that's not very big anymore. Yeah. And then there would be an equally large machine to put next to it or somewhere else. So, that's great, but I think also there is a need for something between the local sort of, many organizations now have a DGX in their cellar somewhere, somewhere between that.
I don't have it in my cellar yet. I would love to have it in my cellar.
You should. No. Something between that, having one or two machines and having 60 machines. We need something close to data, Also to be able to prepare for the super large project, to do the experiments, to do your groundwork properly, and then take your stuff to have to so you don't have to use so many hours on the really big pods, basically.
But okay, so then when you found this out, did you just abandon the whole application, or did you submit it anyway, or what was?
No, there's no idea to submitting it to the Research Council. But the application is still sort of half-baked, so we will try to pitch it to other funders.
EU or?
EU, and also perhaps the Swedish Innovation Agency,
Right,
Vinnova.
Vinnova.
Yes.
Okay, awesome.
I haven't talked to them, so this is the first time they hear about this. Hello, Vinnova.
I like this is the scoop channel.
I mean,
we want your money, please.
We had at least one, or do we have 2 people from Vinnova that's on the podcast? Right? I think it's 2 people.
Yeah. I hope they listen. Yes. So we had this is a really good, strong case. It would really sort of, you would really get the good leverage on the data resources that we have and the competence that we have at the library.
But if I try to follow now, is one of the topics here really that we need to have compute close to the data and close to the competences around that data? And sometimes, yes, we can have one big central pod, but not necessarily would that central pod have the competences or the data even. Is that some sort of point of in case here?
I think we have to have, from a national perspective and from a EU perspective, we have to have different levels of computing sort of resources. And it's important to have a really big pod nationally that we can do really big, super big models on.
But you would like them to be quite... The stuff that goes onto the central one should be a little bit baked, or should you
want to prepare before you sort of take that kind of resources before you use that kind of resources, because it's super expensive. So if you don't use your own money, you're using someone else's money. So it's a good thing to be prepared. And
here then is a gap between the smaller.
Yes, exactly. So this should be some mid-size, and still I think 8 or 10. DDX machines, that would be a good thing. That's it's a considerable. You could do stuff with that.
But what do you think about the approach for Sweden then in general? If we think about, I guess the public sector to start with, or perhaps private sector as well. There's been you said yourself companies are starting to buy their own DDX machines or some at least computational power. Do you think that's the right way to proceed, or should we really start to collaborate in some way, have some kind of centralized national center for AI compute? Or, I mean, we have it to some extent.
Yeah, we have it to some extent. Yeah, I don't know. I see some of the DDXs around Sweden that are not used. They get this resource. They heard that they need this resource, and then they don't really have the competence to sort of to actually paralyze.
Because I think if we speak about you as KB, of course, can't move the data outside of the organization without having the proper legal work in place. But I think that's the same. I mean, I remember from Spotify, there is no way you can move the data outside of the organization.
Exactly. Yeah.
I mean, even if you're in the cloud, you have to be an organization that owns those machines, even in the cloud. So moving the data outside is completely no-no.
Yeah, it's very complicated.
But that really speaks for, we have the central machines and all that, but then they kind of need to build up different domains where you can have these different centers where you can organize, you can have the competences, and you can have the legal...
So I guess what we wanted to do is, since we can use the cloud, at least the commercial companies have gotten some way on that. I think some public sector potentially also is starting to use private cloud or public clouds as well. But what we're lacking is, imagine if we had a Swedish cloud where you still can have a very secured with encryption, etc. Way to move the data there and process it without leaving the organization in some way. As you can do on Google and Amazon and Azure, etc.
Yeah,
that would be a nice solution, right?
Yeah.
Then you could even move KB data onto that so-called cloud, and a lot of things would be solved.
But what you're talking about is a Swedish cloud, where essentially then you can have several different domains, or.
Just as Google does it, they basically have an organization, and within an organization you have projects, and within, you can't really move data between projects easily, and everything is encrypted differently, and then it's really high security.
But there's one huge data center, of course. The infra is not the problem anymore.
But I think Google Research Cloud and KBLab, basically, I think that's a fantastic infrastructure they built. And the problem is, of course, that since it's an American company, ultimately American authorities have the right to access data if they really want to. So that's the big sort of... we can't get around that from a European perspective. So, but the way they built that is something to look into, because it's really, I mean, it's convenient and easy to use and everything. So,
and maybe so the fundamental idea how to do it is not that novel anymore. It's solved, right?
Yeah.
But then we need to bring it home to our European context or even Swedish context.
Yeah. And there is a problem because the HPC environment in Europe, where the European Commission and the member states are putting a lot of money into this to build these computational pods like everywhere, they can't really compete with Amazon and Google because they're not allowed to. So they're sort of, I don't think they can have solutions in the exact same way and sell it to private companies, because then they will destroy the market.
But this is actually similar to, we speak about the so-called AI divide a lot, and one of the parts of that is we have these kind of big companies. They all have their own cloud solutions. Google, Microsoft, Amazon, etc. has their own clouds, and the same in China. You have Alibaba and Baidu, etc. They all have their clouds, and that are really powerful. But we don't have a single European or Swedish cloud that is even close to the same kind of size in scale or in functionality.
Yeah, that is a problem.
It is a big problem, right?
Yeah, it is.
Well, why do you think that is? Why don't we have a private company that's built up a cloud solution that is similar, at least in function in some way?
Because when the sort of GDPR, the effects of GDPR legislation, when that sort of hit the European countries, then that's when as I understand it, the European Commission started to build the HPC, and they were sort of in a hurry and sort of to build computers everywhere, and that was a good thing because we can use them, but they haven't really. I think there is. I don't know. I think it's. The problem, I think, is that it should be a private company doing this in Europe.
Why?
Because I don't think the authorities can really compete with the private companies. I think they're basically not allowed to. You can't really have member states and the European Commission dumping the market, as it were.
Well, probably not the best way or company to build it either. If the EU Commission is leading the technical solution.
So I agree with that, but still, EU and the governmental sort of the money we have, we could help facilitate or grease the wheels, so to speak, on making that happen. We could basically make that opportunity. We could even have calls that is pushing in this direction. And when you are successful with this call, eventually, like even Vinnova, and we are doing calls in order to bring up AI startups. Why don't we do a real call for an AI scale up?
Yeah. We don't really have the big sort of AI service providers or companies like Google. We have Spotify, and what else do we have?
A different magnitude than. So I think you need to. All the US and Chinese ones, they started off just finding a way to scale their business and make a shitload of money, and then later they created the cloud.
Which then they could branch out in a new business model based on their cloud. Amazon is a good example.
I think it's hard to start in the other way, to start with a cloud and hope and make that successful. Without first having a super successful scalable business.
And why is that? Because I think you're right. But let's bring that home. Why is the business angle needed first before, so you don't only build infrastructure?
It's such a long-term investment, I think, to actually have a cloud that works properly. And if they build the business first, they actually use and have to scale up their business, they have to build an internal cloud. And then they can simply take that internal cloud and start to make it public. They don't have to build the public cloud from scratch. They already have it internally.
I think
and they start to extend
to have a real case and a real business, that ultimately drives the true usability. I think that's another angle here. Like we say it all the time now. In the best practices in innovation or creating new services, get yourself your beta customers super early, so you know what you're cooking in the lab is valid and useful in reality. So I think that angle, to have a real business, how do we want to work in order for this to make sense? I think going out of the theoretical lab, so to speak, it tests your idea in a completely different way. I think that's a good angle as well. Why we need the business first.
I think it's strong to start with the cloud as a first business that you have.
Yeah,
if you can't.
I mean, there is a case, of course, for European authorities or to the Commission even to build such a cloud. They're the one with the sort of financial muscles to pull it off.
Then what clouds do exist? Well, we have private cloud provider in Sweden who are very much focused then on high security or virtual private clouds or whatever. So they have a very niched angle where or public data, for instance, right? So these players are coming up, but they're on a very small scales in comparison.
Which one are you thinking? I'm not sure which one you mean.
Oh, I can't remember their names, but there's a couple of providers out there.
But I think the scale is a problem.
Bahnhof? Bahnhof. I don't know.
That's an ISP.
They're an ISP, right? But there is a couple of. I forget the names. But
you can even take like AI Sweden. I mean, they had the idea of the data factory, which in short is some kind of cloud service that allows companies to use their computational resources. But the scale of that is they have like a single DGX machine or something. And of course, that's not anywhere near.
So Google Swedish private cloud. Swedish private cloud. Like as you Google that, see what happens, what comes up.
But are you thinking virtual private networks, or what are you thinking about?
I can't find
because all the big, public cloud providers also have private cloud offerings, basically saying we can provide our software on your private machines, so to speak.
Yeah.
So that exists, but
there are many business solutions that I've seen in Sweden where they sell something, a product or whatever, a model or an application, where they use Google Research Cloud.
And Azure a lot.
And then becomes a problem, especially for governmental agencies and municipalities, etc. They can't do that.
True. Awesome. Interesting topic, and I'm sure we get back to this shortly as well. But let's start with welcome you here, Love Börjeson. It's a true pleasure to have you here, and we've known each other, I'm not sure for how many years, but a number of years at least. And we had a number of very, I think, interesting discussions, but also collaborations, both from Peltarion and other companies. And I mean, I think, also it's rare to find someone that actually is so prominent in the small sphere of AI experts, so to speak, that also know, sorry to say, a lot of technical details. I'm not sorry for all the others, if you see what I mean. What I'm saying is, it's nice to talk to someone that do understand the technical details of how to do large-scale language model training and different models, etc., pros and cons with those. And I've very much enjoyed all the discussions we had about that throughout the years. And he also was like a finalist for the AI Suite of the Year. That is an awesome thing, of course. And I think that's very well deserved, given all the huge positive impact I think KBLab have had on actually using AI for Swedish text. If we hadn't had that, I think we would be very far behind compared to where we are today. And that's a super important thing for Sweden, simply. So very well deserved, and great to have you here, Love.
Thank you, Anders. It's great to be here. So,
should we start with just a short introduction to who you are? How would you describe yourself? Who is Love Börjeson?
Yeah, so I'm the head of the KBLab, which is a data lab at the Swedish National Library of Sweden, and it's a research infrastructure. We provide researchers with the access to KB data from the National Library. KB, I should say, is the short for the Swedish National Library.
Kungliga biblioteket.
Yes.
Together.
It is a national.
Exactly.
It is a national library, but it has royal sort of history. So it's in Swedish.
What is that kind of connection to the royal?
Well, the library's collections, the origin of them are the private collections of the Vasa family.
I see.
In the 16th century, and then during the 17th century, when the sort of Swedish unit state was organized, we had the first deposit laws. So everything printed in Sweden, one copy needed to go to the library.
So for how many hundreds of years has that law been in place?
1670 something.
So essentially every single thing printed in Sweden, one copy should be in the...
Yes. And that includes books, newspapers, what we call ephemera, which is commercial leaflets, etc.
Even commercial leaflets?
Yes. Any convolute for a CD or a record or anything like that. And step by step, this deposit law has been extended. So now we collect also everything web unique. So if something is born digital and doesn't exist in another context, it also needs to be deposited to the library.
From any Swedish website?
Yes.
So you are scraping the Swedish web?
No, they are required to send to us. If you publish something online, you're required to send to us.
So if I'm as a small company?
Yeah. So there's a whole thing about that also, to sort of have people actually sending stuff to us and versus scraping. We also do scraping, of course, but the good thing with the deposit laws is that we get behind all the paywalls, etc. And also computer games, all radio broadcasts, TV broadcasts, etc. So we have
Swedish radio as well.
Yes.
So you have text, of course, but also video.
Yes.
And audio.
Yes. And the web, yeah. So
what size are we talking about here?
For the library as a whole, I think it's more than 25 petabytes of data.
That with text, video, and audio, and images.
Yeah. So it's a lot of data, and it's a new situation also for the library, because it used to be books and ephemera, and that's big enough. Ephemera is everyday prints, but now it's sort of a sea of data. So that's also one of the libraries, one of the labs, my labs, sort of. Can we use the abilities and the things that you can do with transformer models and other models to describe the collections?
And before you get into all of that, I mean, the deposit laws, or the pliktlagen, I guess it's called in Swedish, right?
Yes.
Or,
yes.
Yeah. How did they, just store that? I guess they had like papers and stuff and tapes or something in the beginning before it was digitalized, or how did they just store it? Yeah,
well, any format you can think of historically, we have them. So we have stuff that is on pergaments, and then on paper, etc. And then we have every technical sort of stage in history during the 20th century. We have them. So there are CDs and there are tapes, etc.
Are you required to have like weights to play all old formats?
So we have experts at the library who swipe the internet and trying to vacuum the internet for parts for old machines to be able to digitize, very weird Betamax, etc.
Yeah, exactly.
And if I go all the way back to pergaments,
yes,
are we digitizing copies of that as well?
Yeah, so we're behind on digitization, and we will always be. But the oldest items in the collections, I think, is about 1,000 years old or so. So the collections span more than 1,000 years.
Really?
What an amazing treasure!
Yeah, it's an amazing treasure. But so yes, the digitization, especially of the old rare stuff, that's research driven. So it gets digitized when someone managed to not only apply for money but also getting money to digitize it, and then we have.
As part of they want to use it for some research, and then you digitize it, so you don't have to use the old pergament.
Exactly.
How do you keep that data safe? If we just speak about the digital data, I guess, if some kind of fire were to happen, or if a KB were to be bombed, then I guess we would lose a lot of stuff.
Yeah,
right?
so there is actually another governmental agency who has the responsibility for the so-called, I'm going to say a Swedish word now, bortforslingsansvar.
Okay.
The sort of taking stuff out of their responsibility, if that could be a term. So there's a plan for that, a contingency plan for what happens if we get bombed. But if we go to the digital data, everything is 2 server holes. There's 2 copies of everything, and then there's a copy on a tape. where you actually, to destroy that data, you need to do it physically, basically. You can do it. And the perspective of the...
Two separate data centers that are not physically close is trying to keep it safe. Okay.
And then also a copy on tape in the end, so to speak. And where were I?
Awesome. And but before we get more into KB, I think that's interesting, and specifically, what is KBLab and what is their mission, and what how did it get started and everything. That would be really fun to hear. But perhaps before, what did you do before you got started at KB?
Yeah, my dark
history.
No, so I did a postdoc and was a researcher at Stanford University, computational social science lab. So academically, I would label myself as some kind of sociologist. My background is Stockholm School of Economics, which is my alma mater. So I have a
sociology, or was it more economical kind of background? What was your focus, you would say?
So when I studied business, my major was in organization theory, which is a variety of sociology, I would say. So at Stanford, I did what is called sociology of knowledge, which is how do ideas appear, who leads and lag in that process, etc. Which are the ideas are attractive and can boost your career or not in a scientific environment. So we were looking into large corpora texts, scientific texts, and trying to model latent topics, etc. And relate them to different covariates, gender.
So it was more computational as well at that point. So you used computational techniques at least to understand that.
And ML techniques like typically topic modeling.
Yeah. And can you just speak about Stanford? I mean, it's one of the most renowned universities that we have. How would you describe what Stanford is, and potentially different from other universities?
Yeah, well, so it's in California.
Enough said.
I think the spirit of Stanford University is the same as the Free University of Berlin. Which I think now is called Humboldt University. I'm not sure, but I may confuse the names here. But which was
perhaps, or no?
Yeah. So the idea is it was a break with the traditional English universities, more freer, one step away from the church, etc. Right. Sort of emphasizing the freedom of thought, basically. And I think in the maxim of Stanford University is where the free winds blow, or something like that. In German also, so they're sort of very clear. They're sort of speaking with the Humboldt ideas. Right. And it was started by some of the railway titans of early America. Sort of building. First they wanted to be a department to Harvard, so they pitched this idea to Harvard, and they were kept in the waiting room a little bit too long. So once they were admitted, they just said, "Hello, we're going to start a new university," and basically, can I say "fuck off"? I think that was what they.
It doesn't have to work. You can say whatever.
Yeah. Okay, that's good. So they started their own university, and this was, in the outbacks back then,
What year was this approximately?
1891.
Oh, you know the exact year.
Yes.
Cool.
So it's a young university, and it's built along the road which the Spaniards used when they were colonizing California, Camino Real. So it's built like a Spanish fortress, or a Spanish convent / fortress.
Why did it become so popular, you think? Why have they been
good
able
question.
to attract so great researchers?
Yeah, I don't know. I think the war was the turning point for the American Academy in large, where actually the Nazi overtaking Germany. Germany was the foremost research country before the Nazi overtake. Yeah. And when researchers started to flee Germany, they ended up mostly in the US. For example, Einstein in Princeton, etc.
Right.
So that was a boost for American sort of academic life in general. And then California, I don't know, this weird sort of mix of academic excellence and industrial entrepreneurship.
Because Silicon Valley wasn't the thing at that time, of course, right?
No, it wasn't. But I mean, there's an old Bond movie, I think, where they're trying to drown the whole valley, the Silicon Valley.
Do you remember, can you say which Bond movie it is? I can. A View to a Kill.
A View to a Kill, okay.
And Max Sorin, the Bond villain, he has a plan to flood Silicon Valley and be the sole provider of chips, microchips. Yeah. That's the essence of the View to a Kill.
Okay. So when you first there, you sort of get the feeling that it's all very, very superficial. It's all about developing stuff and blah blah blah, and it has that side to it, but it's much more profound. I think it is really about the freedom of ideas and.
And you were very happy to do the full PhD, and you thought, what was your thinking about academia at that time?
So I did my PhD in Sweden, and so I did a postdoc over there, and I was, for me, the sort of ambience or the feel to the Californian society, it worked very well for me. I liked it there. I think people were unpretentious and very open. People came from all around the world, and whatever you did, you could be 100% sure there was someone else at the campus who did it better. That was a certain fact.
That's a good thing, I guess. But what do you think about academia in general? I mean, at that time, did you have plans to stay? I mean, you did a postdoc, so you have to have some thought that academia is something for you. Yeah,
I had all the sort of possibilities to stay in academia, and by standard sort of the standard outcome of doing a postdoc in Stanford is to become at least an associate professor.
Right.
But there was something with publishing, this sort of publishing process that doesn't really click with my. I lose interest when I knew the results.
And we've spoken about this a couple of times in the past as well on this podcast. The potential problem with academia, and we can at least see a brain drain happening right now, where people are leaving universities for tech giants or other private companies, and perhaps public sector as well. Are you concerned with what's happening in academia? Do you think there has been a decline in some way? Do you think it can rise back?
I'm not sure if it's a decline, but I think that research outside academia has accelerated in some areas, at least especially in STEM, I think. And artificial intelligence in particular, perhaps. And that is a problem. And we see it in digital humanities, which a lot of researchers do that at the lab. And they're not really on par with what we do in the industry, so to speak, in terms of models and understanding what you can do with these data sets. And I don't think they need to be on top of the sort of latest model at any given point in time. But what they're starting to lack now, because they're sort of, when they're falling behind, is the ability to have creative ideas and to fantasize about what you can do, because they're so far behind, so they're sort of not really you can't really have them in the conversation. And then it starts to become a problem that it's harder and harder to sort of to close that gap, and that is a problem.
Do you think we should spend more time as policymakers or politicians to try to reclaim the power that universities have had once?
I think one of the strengths of Stanford, if you get back to that a little bit, is the focus on data and what you can do with data. So that's sort of more emphasis on data compared to
the model
theory. Not that they don't do theory, but it's a different sort of. And in AI, you have to have sort of a deep understanding of data, and it's basically part of the algorithm. And I think that understanding, there's a lack of that understanding in Sweden
And elaborate now, because I sense a deeper meaning in understanding data. Do you mean the contextual? What do you mean with understanding data?
Basically, every aspects of data, sort of understanding scale a little bit. Because when we talk big data now or big scale in terms of, for example, the Swedish National Library collections, the scale is sort of beyond what they can even imagine in many times, you know. So just understanding that this, you will, if you want to engage in that kind of massive amount of data, you encounter new problems that will be analytical, even though it's just about size. Just presenting data on a disk will take you hours, for example. So you have to approach it in a different way. Also, that you can see when when you close in on a map, you close in, and then you can see more and more details. So you can see different patterns when you close in. But the same is also true when you zoom out. Then you can see new patterns, and that's very true about data. So you can see latent structure that are completely hidden. On a smaller scale, they will appear on a larger scale, and with stronger models, etc. And
so what you're highlighting here is in Stanford, they have taken an interest and they're excelling in this fundamental, deep understanding of data.
Yes, I think so, and it's a very vivid and more profound scientific discussion around data than I think that many Europeans sort of understand. With many good exceptions, of course. I mean, most of the researchers at Stanford are not from the US, of course. I mean, that's also a thing about California. It's sort of.
But just so I understand, why is this so important? Or why, if we are lacking this deeper understanding of data, what is it blocking?
It's what I would call the methodological game or play that you have to sort of expand your horizons and do new stuff. To be able to have a fantasy about that and think in terms of data, to really move forward, you need to have that sort of.
So if I put words, see if I understand it. I mean, like the opportunity with data and what you can do with data and how you understand this opportunity landscape.
Yep.
If your vision is too narrow on data, you don't see how you can reinvent things as much.
Yeah, and we see many researchers when they come to us kind of late in their applications for funding, etc. They have not typically, they don't have a data scientist in their project. They think that we can think out the cool stuff, we can think about the stuff that we're going to do, and then we have some IT guy or data scientist in the end who's going to sort of do this. Some minion, who's going to do the data stuff, as it were. That doesn't really. I think data science has to be recognized as some sort of intellectual strand in its own right. And if you don't see that, then it's very, very hard to make use of it.
But sorry, this is profound, because if I take it back to a business perspective, what you are saying now is that when you are trying to develop something which has data and algorithms in it, you need to iterate back and forth between the domain problem, the business problem, and the data problem to reimagining the process, and you will come out with something else. If you're not doing it in that, you're essentially slapping data and AI on top of analog thinking.
Yes. So that's a very well formulated. Thank you for clarifying that for me and the listeners. Yes, that's exactly what's happening. So, there's the reasons for not doing it. I think there's lack of knowledge, but there's also lack of will to do it, of course, because there's a new sort of hierarchy of different knowledge domains where a lot of people don't want to see data science being sort of important on a different level in different contexts, but also from data scientists themselves, perhaps to be hesitant to sort of really engage in, for example, a business problem or a problem with sociological research or whatever sort of. So it's a mutual.
What do you think about Karpathy? The person in charge of Tesla and their autopilot, he wrote something that said, let's see, he basically said, AI, if you combine it with traditional software engineering, it will be like software 2.0, I think he called it.
Yeah.
I'm not sure if you heard it, but basically it's trying to say something that if you use, you can see data as a way to automate how the code should work. Mm-hmm. And by having algorithms, you can then, using, for example, AI, learn part of the software automatically. And that is like a big shift from software 1.0, where you have to hard code everything manually.
Absolutely, yes.
Do you think this is a good way to phrase it, or do you think it will be basically natural in the future that if you build some piece of software, you need to use data to also build up the functionality of that piece of software?
Yeah. Yes, I think so. Mm-hmm. The typical case at the library is metadata, which are descriptions of the collections. And traditionally, what librarians do is to order the collections and structure them. So, and this is made primarily for other librarians, so they can find the books and lend them to someone who needs the book. So the librarians are themselves the super users of libraries. And the metadata sort of standards are built with that in mind. But what we can do now is and the descriptions of the books they follow, this is a novel, blah, 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 blah. It could have certain topics, etc., etc. Mm-hmm. What we can do now is to automate this process and base the metadata on the content of the digital object. Mm-hmm. And then we can have a completely new kind of metadata. For example, an image, it could be what kind of objects are in this image. Is it a cow? Mm-hmm. Is it a road or a boat or whatever? But it could also be more abstract terms. Is this a painting or a photo? But it could also be sentiments. So that's one thing we can do metadata on, a sort of completely new kinds of metadata. But also, we don't really need to do it from the library perspective. We can have a framework for users to create temporal metadata that we don't need to save.
Like personalized metadata? Or?
For example, if you're interested in the collections of images, you can bring your own image and sort of, can I have everything that looks like this?
Right.
Super
or
cool.
Can I have everything with the logotype for a Swedish company? And yes, here they are. Or can I have every sad image? Or can I have every text that has a sentiment of this and that, or that is about this topic, or have these entities, etc., etc.
So basically, you're saying if we can, instead of having the manual process of having to define all the metadata, if we can automate that with software and algorithms, we can have a completely different way to produce the metadata and use.
Yeah, metadata could be something completely different, because the initial thought is, of course, can we automate the metadata? Applying metadata to the digital objects. And to some extent, yes, we can do that. But the real question is, why should we? We don't need to save this metadata. We can just have a framework for the users to create it. And that sort of flips the whole, what should I then do as a librarian? If I don't really control the descriptions of the objects anymore, but users can do that. So the only thing we have to keep track of is the identity of the digital object, and then we can describe it in different ways. Yeah, so that's a whole different sort of...
because you're opening it up that as long as we can find it in different ways, search in it completely differently, then we open up an unlimited view of how we can define things based on our imagination and based on a fundamental, a very singular purpose.
Yeah.
In a way that, if you try to build a metadata structure that is sort of standardized, it will not be as fluid, ever.
No, never. Because if you think about researchers, we can never, ever imagine all the weird research questions that people come up with.
That's a good example.
For example, a typical research question that I'm actually interested to look into is how often and to what extent do food chains expose meat on the first page of the commercial leaflets? Has that gone down in sort of Is that a reflection of the trend of people eating more vegans being around, basically? Can you see that?
Right.
We don't have metadata of that. Of course, there's no metadata standard in the world that would say,
amount of meat on the first page. Please have that tag.
Exactly. And now that I come up with that idea, there's still a million other ideas that I haven't sort of even thought of. So it's better to sort of hand over the control over the metadata to the users.
But that's a complete. You're flipping it completely.
Yes.
And made possible, I guess, by smart AI systems that doesn't have to have hard-coded metadata, but can understand.
The core text, understanding the core content instead of tagging the content.
Yes.
I guess it brings us back to KBLab. Can you just talk a bit more? What happened how did you get in contact with KBLab and why did you get started there?
So I was hired to start a lab. This was in 2019. And KB had recognized the rise of digital humanities and the need for a data lab, because before the lab you could access the digital collections object by object. So you could go to the library and look at the digitized newspaper page and then
on
flip
their web page, or how do you do that? Or in their computers?
In their computers on site, on premises. Yeah. So the library didn't have a concept of data set, and the researchers wanted data sets. So that was the sort of first task for the lab. We had 2 designated research projects.
Why did you want to serve researchers, by the way? Can you just elaborate a bit more? What is the mission of KB and KBLab?
Yes, so the KB has, in the basic instructions for the National Library as a whole, there are 2 parts. The first is to enhance the quality of Swedish research.
Okay, yeah. So that's one of the core missions that they have.
And our department is not the Department of Culture, but the Department of Education.
Yeah, right.
So that's how we sort of sort. And we also have money actually from the Culture Department as well, but the sort of primary department is the Ministry of Education. Right. And the second part of the library instruction is to promote a positive development of the democratic society.
Right.
So these 2 sort of. And the library is very much geared to the first one, to enhance the quality of Swedish research. So that was a part of that, basically. How can we provide research within digital humanities to access the digital collections in the form of data sets? So that was the first thing we did. And when we started out, we didn't have tables or chairs or anything. And I spent a large part of that summer running around in the IT department looking for, computers. And
basically a workplace, you mean, like tables?
Tables, but also computers. And,
You're really building a lab physically.
Yeah, it was a kind of a garage project.
So cool.
And we were 2 persons. We had a product leader also, but it was me and the lead scientist at lab, Martin Monfte. It was a fun time. But then we started to build up the first sort of wave of infrastructure. We decided that we can endure stop in productions. We can buy hardware we don't need professional hardware, so we can buy faster, cheaper stuff. And when they break down, we just replace it.
It's like big data era. You buy middle range hardware instead of supercomputers, high end.
Yeah, exactly. And we didn't want the researchers to have to access it through like a server system, but we wanted to have them full control of their own workstations. And so we just set up the Linux environment, and then they can install whatever software they want, and we would help them to get the data sets up on their local workstations.
And you're speaking about having a computer inside the on-site, so to speak.
Yes, on premises.
On premises, okay. So the research came physically to KB and did the research.
Some of them are still there.
Okay.
They never want to leave. So that is a problem. And a lot of researchers, they can actually be upset about that. Why can I use the data outside the library, etc.? There are legal reasons for that, of course, too. It's not that different from other kinds of research. If you think of an archaeologist, for example, they have the digging site, and it's somewhere where people used to live in the Iron Age or whatever. They can't really move that around. It is where it is. And this is the same. You have to go to do this on site.
The archaeological site.
Yes.
So what are the legal constraints here? I mean, I guess we get into copyright issues, or what are? Can you just elaborate a bit more? Why are you not allowed to move the data outside of the KB?
Yes.
On premise.
So there are three main sort of areas of concern. The first one is copyright.
Yeah.
So KB doesn't own the collections or the copyright for them.
Yeah.
So others have the copyrights.
Right.
And that's very, very difficult because typically, for example, an article in a paper, not even the publisher has the copyright to that, but the individual author.
I see.
So it's very complicated to get license for digital objects or digital collections in particular.
Right.
So that's always an issue.
Yeah.
We can buy group license. So there are ways around it, but then again, the overhead very quickly sort of.
You mean you can buy like a group license from that publisher or something?
There are organizations who handle the group licenses.
It's like in music with Steam, basically.
Yeah, very similar.
Collective societies, basically, in some way.
Yes, exactly like that. So,
okay, nice.
Which is both good and bad, but because sometimes they claim to have. They want us to pay for collections where there aren't really any practical copyrights that are active. So copyright, that's number one. Number two is GDPR, so integrity reasons. And you may think, okay, everything at the library almost is published already, newspapers, for example. So how can that have GDPR issues? But there are interviews in papers during the 1980s. For example, the famous author is talking about her kids having wetting their beds, for example. And these people are now grown up, and so they will have their whole childhood on display. So if you spread this stuff around again,
but if it's still if it's already published and indexed or whatnot,
it is. But it's the scale of how it's spread is an issue. So it becomes an issue, especially if you sort of accumulate.
Do you have content that is not publicly available as well?
Yes. Stuff that is illegal to display, but we can't throw it away. So that's the difference between an ordinary library. One of the central tasks of an ordinary library is to throw stuff away. Yeah. We never do that, not even with illegal content.
Can you give an example? Illegal content, what does that mean?
So this is material that is not accessible by the public. I want to stress that very clearly, but it could be child pornography.
Yeah. Okay.
So that can only be accessed by the police.
Right.
That work with this,
So they actually send content to you because of the law, etc. And it's.
I don't know the context of how that came into the collections.
I see. Yeah, that's a concern for sure. Okay, so GDPR then, I guess any kind of news article can contain personal information.
Yes.
And even though it's published, it's still not allowed for you to republish it in some way. Right?
Exactly. So it could always be a problem, especially if we accumulate it into a data set, blah, blah, blah. There could also be a problem that if we accumulate stuff that could be... the collections are far and wide and old, so there are stuff that are racist or homophobic, blah, blah, blah. And if you put that together in a data set, it sort of becomes problematic. It can be, so...
Cool. So copyright, GDPR. You said the third thing potentially.
Yes, security.
Security.
Yeah. So the data, we have two security sort of issues at the library. The first is we don't want data to get out of the library.
Right.
The other thing is that we don't want anything to get into the library that we don't control.
Right.
And that has to do with the integrity of the collections. So, for example, what did Stefan Löfven actually say on that interview, this and that date? There can't be any sort of... We have to be absolutely certain about the digital object and the integrity of that. So we have to. So that is the big issue. We can't really have stuff in the data that's not.
Are you concerned with someone being able to plant a ransomware and just delete the whole data set somehow?
Deletion, that's not a problem. I think a bigger problem would be to plant stuff. And you can do that legally. I mean, yes, if you publish something, we collect it. So, so that's a problem. But also for data coming out, it could be a problem because then you could train an algorithm to reproduce a Swedish newspaper, for example. So that's a perfect way to make fake news, basically. So.
Awesome. And I just want to stay a bit longer on the legal aspect, because I think a lot of companies are so afraid about this, and it's an important topic. But okay, you can't move the data outside of on premise, so to speak. But then you can train models and you share them publicly. Yeah. And you have done an awesome job, I must say, to share so many different models, and we can go through them later, or at least some highlights of which models you do provide. But I think you have created common license for those, right? What's your thinking about models? Is it completely safe to share models?
I think 100% safety, we can't really achieve that. So, I mean, the models do contain a vocabulary, so, and they do contain a statistical connection between the words and the vocabulary. Yeah. So they're not empty. Yeah. But they don't really have knowledge about the world, you know. Yeah.
So if you were to be able to reverse engineer them somehow, I mean, I guess it's a low probability, but
there's not zero. I mean, the risk is not zero, but it's very, very low. But there are coming, as you know, there are coming models that are of a size and has the capacity to do stuff, generate text, etc. And models that we will not release under CC. Yeah.
And we should get back to that shortly. And I guess for people that don't understand it, of course, it's GPT kind of models that we are thinking about, and other large-scale models. And it's an interesting topic. But I'm super glad that you are able to publish, even though it's not zero, risk for publishing models. The positive value that they do provide is, of course, really, really good. Yeah. So really happy with that. Are you publishing any code as well, by the way?
Yeah, both code and some data sets that are completely open. For example, governmental investigations, SOUer, statliga offentliga utredningar. Right. When the government issues an investigation about something, that's a pretty Swedish phenomena, I think. And a very sort of, from almost any perspectives within humanities or social sciences, very interesting data sets. So we can publish those openly. Also some training data sets.
Who are your biggest target audience or users of your data sets?
So from the beginning, we thought that we were, the main users of the lab would be scholars within digital humanities or closely related, so basically digital social sciences. But then once we started to make models, they are used in a different way because you can use the model without being on the library on premises. So they are used in the industry mostly. But ours we don't build the models for the industry, we build them for academia basically.
But and the core idea here, the core premise is models around Swedish language.
Yes, built on the collections.
So you can then basically imagine how many use cases can we have where we would like to be able to really understand Swedish text.
Yes, and so the first month, I think, when we released our first language model, BERT, KBLab, we had 1,500 downloads or something, and we thought, okay, so this is the peak, and now it's gonna sort of flatten out. And now, monthly, we're between 30,000 and 40,000 downloads.
So this has really been successful in terms of people are realizing if I need a Swedish language model like BirdBase or something similar, this is the go-to resource in Sweden right now.
Yes, it is. I think our KBBERT, the base BERT, is still the sort of base model for the Swedish language.
This is just a start.
And then we have a BERT Large, which is actually performing slightly better, but in terms of efficiency of the models, that would be something interesting to talk about also, basically. But it's better, but it's much larger, so it's harder to use.
Yes. So I'm almost tempted to say size doesn't matter, but it does in some way, but not necessarily positive ways.
Yeah,
right?
I mean, like, it's ultimate efficiency. You know, the complexity of using it towards the use case you're doing it with. Of course.
And I mean, internally, we do not. We use sort of more basic models to do stuff when we want it to be speed up. You know, we can't use transformers all the time.
Remember the sizes of these? So KBBERT, I guess, is 300 million something. Or?
So the large BERT is 340 million.
Could we unpack what we are talking about when you're defining size for a language model?
So that's the number of artificial neurons in the network. So the models are built, the artificial neurons in a big network. And they're organized in something that since I work in a library, I would say they're organized in something that would look like bookshelves. With increased complexity from the sort of
nice
input
metaphor, I think.
Like from the input side. So the first row of bookshelves will be about something really basic about language. What is a letter? What is a word? And then it will be more and more complex. And in the end, you will have bookshelves about really complex stuff.
I bet you this. I need to test. You needed to find a way and a metaphor to explain what the hell you were doing for your bosses that are library people.
Yeah, probably.
Because you said that story before.
Okay.
I was guessing.
No, I think that's true. I think it's true. Yeah.
But these metaphors, we actually really need them. Yeah. And and typically we need metaphors that connects with whatever domain people are in. So it's interesting that you have the library metaphor here.
Should we go to the set of models that you have published and just go through and just a very brief overview of what they do? So KBBERT, of course, is how would you describe KBBERT, perhaps?
So that's a very sort of general language understanding model. And the training objectives of that model, what we learn it to do, might sound awkward almost. So we train it by taking away a word, and the model has to guess what word we have taken away. And
so it's like taking out a book and trying to use your library metaphor here some way.
Yeah.
But it wants to understand basically what the meaning is in some way, and you take away some words from a book in the shelf, and then it has to predict what it is in some way.
Yeah, exactly. And then there's another training objective as well, which is sort of which is the probable next sentence here. But from that training, and the thing that Google did was also a very American thing to do. I think they just scaled everything up. More data, bigger networks, faster computers, etc. And KBLab, you have a model that can perform on a completely new level.
So size matters, according to that, at least.
Yeah, at least
to some extent.
When we started off with the model we had before. And the models we had before, they were sort of so-called global vector models where every word had one context vector. So, so this word has these neighbors typically. But every word had only one vector. So, for example, the word cell, which could be a phone or a human cell or a cell that you live in a prison, or they all had the same vector. So that's the global
like
thing.
Apple, I think, is a very common. I think we used it a bit before. Is it
so
Apple the company or the fruits?
Yeah. So explain so I understand. Are these different vectors when you say cell?
Yeah, but the problem with the global models was that the word cell only had one vector.
So you need to decide: is this a cell I'm living in, or is this a cell?
So the strongest, most common vector would sort of dominate. Okay. So you couldn't really. So it wasn't. These models performed very well, but they were also sort of crude in a way. and with the new transformers, you had a vector for every instance instead. So,
what's an instance? What is instance context? Sentence.
Yeah. Every time it appears, basically.
Okay.
Which is very good because even words that sort of have a stable meaning, like the word man or woman, for example, you can see how the context changes over time. Yes, so the BERT model can't really do anything in itself. The cool thing about the model is that training the model takes a lot of time and data and resources, etc. Once you have the model, you can fine-tune it, and fine-tuning is not computationally expensive, not to the same extent at least. Then you can train it for a domain or a specific task. So you can fine-tune it to, for example, the financial domain, to understand financial language, or the medical domain, or whatever. And you can also fine-tune it to do certain stuff. Find all the entities here, all the names, all the organizations, all the times, all the objects, etc.
I don't understand, but it seems very pragmatic and useful, and not overcomplicating things. That we have a basic model, and then basically like a framework, and then now to try to make that perfect and all-encompassing is really hard. But even a quite basic model now, I now take it to a specific narrow use case.
Yes.
And now I fine-tune it, and it can be really, really performant in a frame.
Yes, which is good, because then others, and that's why it's infrastructure from my perspective, that we provide the model and then others can fine-tune it. And they can fine-tune it to do whatever. So we can fine-tune it to classify whatever text flow you have, basically.
I mean, awesome. And then we have BERT, and you can use it for so many different tasks that we can fine-tune it on, and you can tune it for your own data. But using a really small amount of data for a very large model, and in some rather strange way, it still works to train it on a small amount of data for whatever use case you have.
It sounds efficient in terms of in many aspects, I guess, to me.
Yeah, it's fantastic. So what you basically do is that you unlock the network a little bit and allow the fine-tuning to sort of...
And the point is to separate the fine-tuning to the context and the domain seems like a very scalable way of thinking about this.
Yeah.
Or the reuse.
Yeah, it has become a whole paradigm. It's called transferred learning. So you have to sort of... The basic language understanding, which is in the model, and you have the fine-tuning, which is... similar to human language understanding. You have a basic language understanding, and then you go into your field. Yeah, you go into your field, and then you find yourself in a new field, and it will take a certain fine-tuning to sort of get the hang of things in that new field.
Makes sense.
Yeah.
Cool. Should we mention some other language models that you have produced besides the vanilla BERT?
The vanilla BERT, yeah. So then the next model we built after that was an Electra, which is basically the final product, so to speak, in terms of model is very similar, but the training objective is different. So the model on the same amount of data it's more efficient because it sees more data during the training. That didn't really work out, so that's also interesting to share, I think.
What was the training objective, or what was the difference?
The training objective for an Electra is it will have a small generator that will generate artificial text, and the training objective is for the model to determine this is original text and this is machine-made.
Oh, so it's a completely different question.
Yeah. Completely different question.
And why? What is interesting with this question? The first question, I really, is basic. Why is this question interesting?
It learns to identify and understand natural language.
Okay. I guess it would be fair to say it's one of the take advantage of one of the popular techniques in AI, which is called generative adversarial networks, and tries to apply that for understanding text specifically.
And why do we want that?
Well, in this particular case, you get better use of data, I would say.
And then you had some other models as well. I'm actually not a big fan of Electra, but that's my subjective.
Okay, that's interesting. It bombed a little bit. There was something in the training that we didn't get right. Yeah. So it works, but it doesn't work really that well. Yeah.
Albert as well, right?
Yeah, and we wanted to build a smaller model, so Albert was a natural way to go.
What do you mean smaller?
In terms of number of parameters and how much memory it would be, you have to use to actually use the model.
So even a more efficient model to be able to embed it in other cases, or why?
For sort of low resource users.
Okay.
Yeah.
I mean, it's simply easier to make use of because you don't need as big GPU and it's faster to run. And
yeah.
So you basically, how can we make a model that you can maybe even run on a normal workstation?
Yeah, basically, BERT you can fine tune it on a normal workstation if you have a good GPU on it. But we were sort of thinking about the PhD students with a little funding.
So a little funding PhD student gets something so they can play around with without they don't have the real.
Yeah, and
I love that idea. The garage model.
Yeah, exactly. But I think the next so we have built a bigger BERT, and that's basically the same but bigger, better, but harder to use. Then we have also built a sentence BERT, which I think is kind of interesting, which is
so interesting.
The basic embedding. The basic unit of the BERT vanilla model is the word, and the embedding of the word. The sentence model is the basic sort of unit is the sentence and the embedding of the sentence, which make the model better at comparing text, longer text, etc.
And when does this come into play?
Anytime you want to compare text, which is like a gazillion use cases.
This was actually one of the most popular use case that we had during the Peltorian time. Just being able to search through text. Imagine like a really smart Google search functionality.
Yeah.
Just saying, I want to find a piece of text that has something to do with Henrik getting drunk. Henrik having fun. And then we just write the words, and you don't have to write the exact words, but you have to have the meaning of the words.
The meaning of the intent.
And the whole context, so it shouldn't be per word as the traditional word to vec or glove kind of thing was. Yeah. But instead really having the full sentence or the full piece of text and understanding what you actually were. That Henrik and happy together in some way.
Drinking beer.
And just finding that throughout, tens of thousands of books or whatever.
Yeah.
And normal BERT did not work well at all.
No.
But this is so important the way you now storytell around this, because now
Aren't you having fun?
I'm having a lot of fun, but this now sentence BERT. Okay, sounds really cool, and it can do this. Okay, still blank, blank, and then when you do this storytelling, it makes total sense.
Yeah. No, but so that was an important model, I think, and we can also use it. A few months ago, there came this. It wasn't a new model, but it was a new applications of post modeling, putting it on top of a BERT model, which is called BERT Topic, which is making the output look like a topic model, but with the power of a transformer model, basically. And that builds on. To do that, you have to have a sentence model. And we had one laying around in the lab, luckily. So
we have the model laying around in the lab. I got another picture in my head when I had a model laying around in the lab, by the way.
You're thinking about non-digital stuff, I think.
I don't know what you're talking about. I have no idea.
Sorry, that was a bad.
No, which is really good, because that's in the industry topic. I don't really know, but I think the interest for topic modeling is not that big in the industry. I think it's more of a research thing. A lot of scholars in digital humanities, and they do this for various research reasons. So they want to have a topic model. Topic modeling is tiresome, and the data wrangling and text cleaning and iterations you have to do, it's just staggering. So doing in transformer style, it's very little code and a lot of this sort of pre-cleaning, stop list, all that crap. You just get rid of that and the model just takes care of it. Boom.
I would like to ask a question, but you can allow it or park it. The simple question is, how do you go about, what's the process of building a model? Because we're now defining 3 or 4 different models.
Yeah.
And should we park? I mean, it is a great question, Henrik. And I think especially when it comes to larger models, which
what's the process here, or how
But should we take that a bit later then? Because
please, I think that's why I was asking you to allow it.
I mean, it is a great question, and especially for I think Love, who has done this on a scale that very few other people have done.
Exactly.
So I write it down here, and How to train large language models.
No. You're narrowing my question down. How to go about? What's the process here? How do you come up with it? What do you need to do? What are the key steps? And training is one step, I argue. Mm-hmm. And then what?
Everything about training a model. Yeah.
But
cool.
But move on models. Yeah. Yes. So the sentence model, which is really good in itself, but also to do other stuff. Many use cases are linked to the sentence model. Yeah. Then we have fine trained. We don't do so much fine training because we think that we can do the ground training. No one else can do that. Fine training everyone can do, so we don't really do that.
But no one else can do that because they don't have the data that you have.
Exactly.
Right?
So
or the competence or the compute resources.
Exactly. But we have, in spite of saying that, we have actually fine-tuned a couple of models that we thought were we need to have this. It's like having milk and eggs in your refrigerator, and that is the part of speech model. Yes. Which identified part of speech. I don't know how to say that in another way in English, but the different kinds of words that you have: nouns, verbs, adjectives. Yeah.
Part of speech.
Yes, so that's a very
ordklasser in Swedish.
Ordklasser, okay. Yes. Ordklasser, nu är jag med.
Yes, so that's a very basic research infrastructure to have that, basically.
We're going into grammar now, grammatics.
Yeah. Basic grammar.
What do you think about that? Though, do you still need to do part of speech when you have BERT models and transformers?
No.
I think it's a wrong direction to go as well.
Absolutely. Right? If you want to go into grammar, there are much more interesting approaches like functional grammar.
So please rephrase the comment or the question or the reflection.
It's just, this is a very common NLP in traditional NLP where you want to understand the nouns to properly understand the meaning. But today, instead of doing the full rule-based kind of grammar of, what is the grammar of language, you instead, do it fully data-driven. Yeah. You just put in the raw text and it figure out the meaning without knowing the part of speech.
Yeah. You don't need to teach it grammar to make this understand
so this is trying to predict the grammar, and you don't need to anymore.
We have sort of a little bit of a keyword in the lab where people want to talk with us about traditional NLP, and the keyword is morphology. So when people start to talk about that with us, we sort of, whatever. But we have the models, and whatever you're doing, it does this better. It doesn't know anything about morphology or grammar or whatever, so it's just power through. So.
And
I agree
but
with
it's a sensitive topic because a lot of researchers have spent their life.
Yeah, and someone comes in and spent their lives on this angle, and you think, well, you don't really need it.
Yeah, and even researchers at the lab, the guy who's responsible for our larger NLP projects, Robin Kurtz, who's a brilliant researcher. His whole thesis was about dependence, etc. So he's just put that away, and
even he says it.
Yeah, I think so.
Cool.
There's
but
still a case for
it's
still a case for traditional language technology, absolutely, but not in the same way, I think. So.
Okay, KB, was it called KB POS or what was it called?
Yeah, I think something like that. Yeah. But I don't remember the exact name. Everything is on the same. You can reach it through our GitHub page.
Right. But you also publish in Hugging Face, right? But not
the actual models are in Hugging Face. They're hosted there.
Yeah, but not all of them, or are they?
I think all of the...
I just had a quick look and I couldn't find much, actually.
Mm-hmm.
It's like
so when does someone go to GitHub and when does someone go to Hugging Face?
So in GitHub you have like how to run the models, fine-tune them, etc. The code for doing that.
Okay.
And then there's a whole ecosystem in Hugging Face where you can actually do it.
Hugging Face is taking over in so many ways.
Yes.
I think it's becoming. If we have this kind of platforms for research articles like Archive, it seems like this is like a platform for models or data sets.
Yes,
and it's increasing.
They're doing a great job, I think. So then we have the spacing model, which is the sort of the traditional NLP library in Python for doing basic NLP stuff. We are actually, within the next few days or weeks at least, we will be the canonical spacing model for Swedish. So we're very happy about
the official model in Spacey Library?
Yes.
Nice.
That's a big thing, right?
Semi-big, yeah. but we're sort of finally. We've been working. It's Elena Fano, who's a data scientist at the lab. She's been working in that direction for quite some time.
And what are we? Just unpack a little bit. What does this mean?
So the spatial model was actually an NLP tunnel. So it's sort of you put text in one end, and then it's stuff with increasingly complex stuff happen to the text, and out you could have semantic classes in the end. Sort of, but this was pre-transformer basically, very efficient, very cool and good stuff. Part of speech, it did everything. Part of speech entities, what have you. But it was pre-transformer. But the whole tunnel was this sort of idea. So everyone can sort of, I put my text in here, and bloop, I have tons of results in the other end. And now we have a spacey trained, traditionally trained, but also trained based on the on the KBBERT. So it's sort of it's a NLP tunnel on steroids, basically.
Super cool.
So that's the spatial model. And then it's the entity model, which is one of the unlike part of speech, entities are sort of a thing that people really are interested in.
Yes.
Which is identifying in a text. It's not grammatical categories, but semantic ones. But so there are persons, organizations, places, locations, times, works, also man-made things, which we are interested in because we're interested in, for example, Astrid Lindgren's book, Pippi Longstock. And we thought, okay, so Pippi Longstock, that's the work. Astrid Lindgren's a person, blah, blah, blah. So that is one of the fine-tuned models.
Very important one, I must say, as well. And if we have to go to, do you remember all the discussions we had about knowledge graphs, etc.?
Yes.
Or knowledge bases, if you want to call it that. This is an awesome tool to build up such knowledge.
Yes.
Ontologies.
Which leads us to the next model, which is the bootstrap model, which is to disambiguate entities. Which we also, Elena Fano at the lab, trained together with the Stanford Computer Science Department of Computer Science.
Really?
I didn't realize there was such a substantial library of models now. I understood you had models, right? But we are up in 10 now, 15?
Yeah, it's about 15, I think.
Busy bees.
Busy bees, yes. So when we plan the vacation, we don't plan who should be at the library. We plan what should the
computer run?
Exactly. What should they train? So we have a plan for that.
Should have a big model during vacation weeks.
Yes.
So Easter is coming up. What is running over Easter?
Good question.
Yeah, we can come into that. But last summer it was the sentence BERT that came out of that summer.
Nice.
And how long is it crunching?
It depends on the size of the computational.
And the biggest we've done is the large BERT, I guess.
Yeah. Yes. The one that took the longest to train was the original BERT, because then we didn't really have computational resources.
Okay. That's another dimension.
Yeah. So that took 7 months, I think.
Oh my God.
Cool. Let's just finalize the list of models.
Yes.
Quickly.
Yes.
I'm not sure which one you can
BART.
speak about. BART, yeah.
Which is interesting because it's both a decoder and encoder, so it can sort of do the BERT stuff, but it can also produce text. We have it to, it's like the much known GPT-3, but it's smaller in size. We have it to sort of put it in the end of our Sun model. We'll talk about that later. to enhance the quality of the speech-to-text output. So it was sort of built for internal purposes.
And speech-to-text, do you have a model for that?
Yes, it's a large word-to-vec model. Vox Rex. Rex is as in royal.
You mean wave-to-vec, right? You said word-to-vec.
I did, okay. Sorry, wave-to-vec, sorry.
Wave-to-vec 2.0, right?
Yes, the larger one. We have a base also, but I think the larger one.
So this is taking speeches or someone speaking? Or
yeah, it's trained on sound. It doesn't know anything about text. So the ground training for that model is just sound.
That's why it's wave-to-vec.
Yeah, exactly. So it is trained in a similar fashion as BERT. Take away sound and then try to predict it. But then you have a head in the end, which is the speech to text. It doesn't have to be, it could be another head, but that's the most...
So head means it in the end it produces...
Yeah, an extra layer which just does something else.
And An extra bookshelf.
Yeah, an extra bookshelf, exactly. That is sort of purposely.
How many neurons is in one bookshelf when we talk about this?
What would that be? That would be
500 or?
Yeah, no more. Sorry, this is
using your analogy back at you.
I mean, cool.
It's cool.
I mean, so you can also not only work with text, but also audio in this case, and then produce Swedish text from audio as well.
Yeah, and think of this in a library context. So we have all the big black unknown sea of data of Swedish radio broadcasts. The only metadata we have is the listings in the newspapers, which are not always correct. And we have the sound comes in slots of 1 hour, so it's not per show. So you have 1 hour that could contain this, from the listings. So, for example, the night that the Swedish Prime Minister Olof Palme was murdered in Stockholm, the listing says quiet music. So if you a researcher want to access that sound or find it, there's no way to really do that. Okay, we know the dates, we can find it, but you can't really search for it.
And it said quiet music because it was normally planned to be quiet music at that time, but then it was completely different audio.
Yes. But with the sound model, we can get the transcripts that was actually said, and then we can use the entity model, and then we have, so you can follow the whole
really
the
powerful
process.
stuff.
So that sort of changes the whole way we can work with that part of the collections. So.
Cool. Space Wave 2.0 as well. And anything else you'd like to mention? Some highlights or anything with images that you have been thinking of? With images in some way?
Yeah. So we have not trained the clip model, but we have translated,
right?
Which is two modalities as well: images and text. So you can write the description in Swedish. I don't know what. A horse, boat, balls, beach.
I think it's better that if you have a large number of images and you simply want to find through these kind of hundreds of thousands of images from newspaper articles or whatnot, find me a picture that contains a man with a cape and a dog. Yeah. And you just write in natural language, man with a cape and a dog.
Yeah, and you will get that.
And suddenly it finds it. It's actually one of the most, I think, powerful models that you can think of compared to SentenceBERT as well. Yeah. SentenceBERT can find similar text. Yeah. This can find similar text, but also similar images. Yeah. And combining the two. It's magic. It's amazing, it's cool, powerful model.
And when you demo this model, it's like, wow. So it's amazing. And also you can, since many of the objects are known, you can actually put entities on them and use a bootleg model to disambiguate. So, okay, so this is not only a church, it's actually this church.
Cool. And the whole angle here is that I'm sure that these kind of models of different, all the examples you made here, I mean, like there's the English versions of them, I guess, or have you sort of starting to go into, we are now, Swedish is the key theme here, right?
Yes.
But I guess when you started going into this field and you actually you have come quite far in this field now because you've been a busy bee, as we said, right? So now all of a sudden there are things that you have produced that, are there things that doesn't have their English equivalent yet? That's used to big research community.
Yes, I think there is when it comes to, but this is a very library specific case. It has to do with the peculiarity of the deposit laws. So for example, when we get newspapers, due to how the law is constructed, and when it was written, we get the newspapers in a physical form, and we don't get the print PDF. And then we send it to a factory up in the north of Sweden, and they digitize it, send back the digitized copy, and that is just a mess from a data sort of scientific perspective because the articles fall apart. We see the text blocks, but we don't know which text blocks belong to each other. Blah blah blah. So we have to sort of reconstruct the whole You can imagine.
It would have been simpler just to get the PDF.
Very much so. And there is a new deposit law coming, so it will happen. But we are very, very. We have come a long, long way on sort of classifying and ranking that kind of data and building models for that using the image models CLIP.
And this is a little bit driven by a unique Swedish law, so we have come extra far on this problem.
But many national libraries has this problem. For example, there's a very fine collection of digitized newspapers in Holland. They have the exact same problem. I think there are many digitized newspaper collections and others, not only newspapers. So the problem is actually bigger than you would imagine.
But here you are quite leading it.
Yes, I think we have come the furthest of everything I've seen. And what we do, well, first there's a combination of models, but also that we have, this is Faton at the lab. He has taken a much less text-driven approach. So he uses text, but only as a sort of later in the stages. It's very looking at the text as well as images.
To make a text puzzle.
Yes.
I think it was actually a recent Google research paper that spoke about OCR, but in a more generalized sense, trying to understand like tables and images and the layout, and took advantage of the layout structure and everything. I don't remember what the name was right now, but it was it's a tough problem for sure.
It's really a tough problem, and yeah.
Awesome, and the time is flying away here.
Yeah.
Should we move into the training model kind of question as well?
If you don't have a better question, that was just an idea.
No, but it's a great question, I think.
Yeah.
How should we start it? Should we just speak from, how do you normally, if you just take the simplest kind of steps necessary to train a model that we can publish on Hugging Face or GitHub, what's the normal procedure how would you describe that?
We're talking ground.
Super simple pre-training things with a KB Birch or something.
Yeah. Well, so the first thing is to consider the data. I think. What data have you? And we have worked now since the lab started basically with data. I mean, that's most of the time. It's just wrangling, cleaning, curating data.
And I think you do that to an extent that most people don't understand, I think, especially with deduplication, etc. And it's also connected to what we said before about the model-centric versus data-centric. Yeah. I think you spend so much time about producing the right data rather than tuning the model to improve it, right? Yeah. Can you just elaborate a bit more? How do you clean up the data so that it has...
First there are artifacts from the digitization processes. When we have digitized data, there's not born digital. So that's heuristic mostly, not model-driven. There are known errors that we can sort of clean away.
Expressions in some way? Or
for example, the word om was OCR'd into the örn, which is a bird. Eagle. It has to do with an oddity in that.
The OCR.
Yeah,
software.
and OM is such a common word and has such an important sort of
so a number of hard-coded rules.
Hard-coded rules, exactly. Yes. So that's one important thing. So it has to do with, we would like to re-OCR, actually. But that's a question of resources and time, etc.
You are thinking that the technology and how you do OCR today is so much better.
It's also transform-based these days.
So basically, you are battling old OCR problems to some degree.
Yes, to a large degree. So that's OCR cleaning, and then we have a huge thing which is deduplication. So everything that someone writes, some other moron has already written that at least 5 times. And then it's so deduplication is a big thing, and I think we have
on article level or on.
So that's a key question. Which level do you look into this? So, and I think sometimes we are a little bit too strict almost.
Going too deep.
On the too sort
low
of
level.
But we want to have sort of different entry points into our data, deduplicated at this level, and we don't really know. I don't think anyone know the effects of duplicated data in the models, because in a way that really it reflects language. So
at least it wastes time, and that's one clear effect, right?
Yeah. But we see, I think, when it came to the BERT large model, that quality of data enhances the model quality significantly. Sorry. So data is really, really important. So thinking about data, so we have the OCR thing, which is sort of heuristic, hard rules, and then we have deduplication, same basically. So there's a tunnel for doing that.
What's the reduction? Is it like to how much from the original data does it compress?
If you're strict, we keep about 8-9%.
Really?
Yes. It's very depressing.
Depressing or compressing?
This is a very compressing thought.
Yeah.
Even I got that joke.
Yeah. So, yeah.
I mean, that's interesting.
Yeah.
It's a lot of deduplication then.
Yeah, because I mean, we could easily scrape, terabyte of web data, and then it just shrinks. But there are other sources that are better. So we also, there's a big hole in the digital collections which are monographs or novels. And there is also an increasingly fast inflow of data. So in half a year we will have much more data. And not only that we add up in the same time, but we sort of the inflow is much bigger.
So here's a lot of stuff summarizing. Get your data in order.
Get your data in order, and the last step, or not the last step, but one really important aspect is also balancing the data, which genres should be represented. What is the purpose of the model? We have to balance data in relation to the purpose of the model.
So, but maybe start there. How do you select the problem, and how do you select what problem to solve, and how do you select, the question to ask?
Yes.
If I take the example of the first bird, how did you get about? What's that process all about?
Yeah. So the standard answer to that is we are a national library. We should represent all varieties of Swedish language, so we can't really take anything away. We cannot take away stuff that is racist, for example, or bad Swedish, or we can't have the nicer text only in our models, because the models will be useless. We want to have models that can understand all varieties of Swedish. So we need to have flashback, etc. But we need to think about the balancing, because if we scrape flashback as a whole, it will be the model would be too, how should I say, geared towards flashback data too much. So we have to sort of think about
how much of the flashback semantics do we want to influence the model with?
Exactly, in relation to newspaper data, in relation to whatever we have, governmental text, in relation to blah blah blah.
Yeah, cool. I'm trying to push things along a bit, because we have more topics to cover, we should have a BERT topic.
So let's maybe do it a little bit more faster to understand the process.
But you have the data part, and I don't think people realize how much work you need to spend here on actually producing the data from the raw data that you have into some kind of pre-processed data that you can start train on. Right? And is that what you spend more time on, rather than how to tune the model and do that?
Yes, I think that's the major part of our time. Yes, but then training is also, training always involves restarting stuff. It involves having training frameworks that doesn't work. We run them.
But if we start on the simple part of it, not thinking like huge clusters that we have to train on. And just saying, okay, we have the data, now we need to feed that into a model and run that on some GPU machine in some way. Yeah. And can you just very briefly go through the techniques? Do you normally use PyTorch, for example? How do you do this?
So nowadays it's different. The ecosystems that come from the hardware producers, they have an ecosystem of training frameworks to speed up, basically.
But now we're speaking like large language models and Megatron kind of stuff, or what?
Yeah.
Okay.
So
but if we simplify it a bit more,
so
don't go there right yet.
No, so if you simplify it, yes, PyTorch or something similar, and you can do it if you just fine tune, you can do it on Hugging Face.
Yeah. So okay, you have some kind of pipeline. You first have the data, you convert it, you clean it. Do you do that do you have like an automated pipeline for doing it, so you can rerun it, or do you have a lot of manual steps?
It's a lot of manual steps, and we're still getting to know the data. Even though we have been working with data since the lab started, it still sort of surprises us. And I would say that when it comes to sort of knowing Swedish text data, it's hard to beat us. We know a lot about it, but still there's stuff that we sort of whoa. No, there's no automated pipeline, but we're sort of getting there to automate the process.
But you are losing me on one topic here. So, and maybe this is obvious for you as experts, but okay, we have the training, we have pre-processed data, and then you jump to now we start training the model. What does it mean to set up a model, or what do you need to build a model? Do you need to take a model? What is that? Is that a part in between here? We train the model. What's the model here?
Yeah. So the model is an architecture of a neural network that comes from somewhere. We don't really develop those ourselves. We are parasites.
And using, for instance,
for example, the BERT architecture that came from Google, and then there are other providers of those architectures.
So here we have the whole open source idea that there are huge, fantastic work done by someone really building the first architecture of the neural network. Let's say BERT.
Yeah, high resource actors typically.
High resource actors, and now basically, okay, so we have this whole neural network architecture now. And now I don't want it to be fed with English text. No. So we are now taking our pre-processed data and pushing that through one of those pre-architected neural networks.
Yeah, and the thing we sort of manipulate a little bit is how we present data to the model. In terms of batch sizes, length of the sentences, etc.
And why is that important?
Also thinking about sort of the downstream task that you want to solve. So if you're going after entities, you don't want too long sentences, for example, and that's kind of intuitive. So you're entering into the dark arts here because we don't have the answers.
And let me ask you a question now. Do you need to know the end game, what question you are going for, before you even start the data pre-processing?
The more you know about that, the easier it gets.
The more clear you are what you're after. If I'm going to build an entity model, you want to have that in mind when you start doing your data pre-processing.
Yeah, but it could also be a problem, because if you start to sort of running off, there's one thing that happens when you have trained a model, it will be evaluated within a framework of tests that it calls GLUE. Which is a test framework, basically. It's available in English, and then we have translated into Swedish, and we're also annotating together with AI Sweden and the Swedish National Language Bank to get proper gold standard test sets, training data and test sets.
But before we jump into evaluation, I think that's basically, these are the three steps mainly, right? You have the data processing, you have the model training, and you have evaluation, and you have GLUE and whatever. And you can continue to annotate it and improve on that in different ways. But just keeping slightly on the model training part.
Yes.
So now you have the data, you start training, and then normally if everything goes well, you just push the button and it trains, and then it stops at some point. But that's not normally how it works, right?
No, usually there's something wrong with the code. That's the first thing.
Yes. So the code is written by researchers, and it's production level code, and it's horribly bad in different ways, right?
It's horribly bad, and it's not transparent in the scientific articles exactly how they're done. Not that people hide stuff, but there's so many things to think about. So, for example, I think that was the thing that happened with Electra. There was some, not the variable, but the fixed parameter that we got wrong somehow, and we haven't figured out which one. And we won't, because there are other better models now.
But I think this is a big confusion for, I remember from Praetorian days, so many companies came and said, what do you mean? It's open source. You have the code there. Yeah. What do you mean? We just feed our data to it and that's it, Why do we need to do anything else? And they don't understand how low quality this piece of code has.
Yes, it's you really need to have your own very high sort of data science competence to understand how to fix broken code, basically, and also to adjust it to your special use case, because we have data sets that will not be, well, it's a different language, first of all, but it will also be different sized, etc., etc. So the whole...
So what does that mean? Do you rewrite code? Do you write out snippets, or do you take the open source code and then, okay, I have this as a template, but now I code it the way I want it?
Yes, a lot of that is going on. A lot of, training algorithms, training sessions that explode halfway through and just stops and becomes nothing. And then, okay, start over. And trying to, you very often you sort of move around in a landscape where you have an intuition about what is going on, but you don't really know. And we can't test, because that will take too much time. So you have to have a data scientists who are knowledgeable. They have to have the technical knowledge, but they also have to have some kind of knowledge on a deeper level, on that level that we call intuition, basically.
Cool. Experience.
So you fight against the code, you tear your hair off in frustration over.
Is that why I thought that was the new haircut.
But also, do you do any tweaking at this point on some hyperparameters, etc., when you run the training?
That happens, yes.
Can you give an example of what kind of tweaking you're doing?
The most obvious thing is how much we train stuff, and the other one is
learning rate, perhaps.
Yes, batch sizes. It could also be that we skip some of the training. We thought we saw.
And then you don't restart. You basically, you do some training, you just tweak a bit, and you continue the training because you don't have the time to restart it all the time.
Exactly. Or you can reverse it a little bit and start over, because you can see some. Okay, so now we're doing it by the book, and then we see signs of the model actually becoming worse. So let's back it up a little bit and try it a different way forward.
Cool. And I really, we only have like 50 minutes left, so I'm trying to really push it forward here quickly and
do that.
But then for evaluation, you mentioned Glue, and we also have the Swedish one, SuperLim, etc., right? And whatnot. Can you just elaborate? What's SuperLim?
Yeah, so SuperLim is the Swedish version of the framework for testing these models, which has become the standard. So every model should be tested in a similar fashion. So together with other actors, Språkbanken, the Swedish Language Bank, and AIAW Sweden, we are making a Swedish framework, basically, the gold standard. And the labs part will be to host the leaderboard, which is interesting, I think, because we're talking about efficiency. So we want to have an efficiency measure.
Not only performance in terms of accuracy, but also in terms of
compute needed.
So that's in discussion. What should efficiency be then? But we're talking about now a very sort of a starting point, at least, could be something related to you relate the outcome to the size of the model.
That sounds great. I guess it's similar to CPUs these days. I mean, it's not only about the gigahertz or the flops they can do, but it's flops per dollar, or it's flops per energy consumption.
I was thinking about energy consumption here, actually.
Right.
I mean, also usability for low resource or even middle resource users.
Yeah. Should we just very briefly as well, when you start training these super huge models on these super big clusters, and I know you have trained it on like these big EU clusters like Viga, etc.
Yes.
And can you just mention how big is Viga and
how many GPUs are that? It's on a petaflop scale. So it's not one of the really large ones.
It's small to compare to some others, but it's still hundreds of GPUs in some ways.
Yeah.
Right.
So we have been able to do stuff there that we wouldn't be able to do otherwise. And also, the sheer number of models that we can produce in this context. So
is there anything different when you train a model on these kind of large clusters compared to?
Yes, it is. There's more engineering-like,
concerns or
so it's the main concern is to have the machine, the GPUs work at as a high level
utilization.
Being utilized as on a very high level, all of them. And that's really hard because you can always make it work, but when you have a big machine, you want to use the whole machine.
Are you doing synchronized training then, or can you have asynchronous batches that you can train on?
How is that on the Vega framework? Using the Vega framework, the Vega pod is NVIDIA based. So yes.
But then Megatron, what's that?
So that's
was that what you used, by the way, for Vega or?
We try different ways to train. And the thing is, we want to align with Hugging Face because that is such an awesome framework to share models and fine tune them, etc. But using Hugging Face in terms of training really large models is too slow. So we need to use the NVIDIA computing frameworks because they know their machines, so they know how to design this to make it work really, really fast. Which is good, but it's not usable for others. So there's a sort of a
trade-off.
Yeah, there's a trade-off. It's easier for us to produce the models, but it's harder for others to use it. So, and then we have other super pods in Finland, etc. that are not NVIDIA based, and then we have to port the code. Blah blah blah.
So Lumi is this big Finland cluster.
Yeah, which is
it open yet, or it's supposed?
No,
still not open. It's supposed to be open, I think, last summer or something. But
so it's open. You can access the CPUs, but not the
GPU cluster. And it's supposed to be an AMD, not an NVIDIA. GPU cluster.
So and a big question for us was: is AMD building their own ecosystem, which would be a good thing? That's their ambition, at least, as far as we understand them.
And why is it good that we have an NVIDIA ecosystem versus an AMD ecosystem?
We want to have competition.
Okay, competition, simply.
I mean, NVIDIA has such a big monopoly on GPU training today. It's a bit scary.
Yeah, it's a bit scary. They do fantastic stuff, but the monopoly is never good. So,
I mean, we have Berzelius, and we have what's the one in Luxembourg? What's that called?
Meluxina.
Meluxina, right?
We're hoping to use that this autumn.
Right.
And do you apply to use it? And so they have some sort of...
you can apply at different levels. Like I think it's A, B, C, D or something like that. Where D is an absurd amount of hours, GPU hours.
You pay for it, or you get granted to use it?
No, as a governmental agency...
They select who should...
and the reason for that is already financed by the member states. So Sweden as a nation actually own parts of these pods, even the ones that are abroad.
Okay, this is the way. So
and to use our taxpayers' money.
Taxpayers' money.
But I'm using your money.
And how competitive is it to get some hours?
In the beginning, it was very easy. Now it's more competitive. I think personally that it's a good thing to have a certain degree of redundancy when it comes to computational resources in society at large, because that reduces all the administration around it considerably. So even though there's a cost for redundancy, the total cost will be lower.
Yeah, because if it's a high competition, do you have all this bureaucracy?
Yes.
Who should get the hours?
Exactly.
Yeah, I get it.
So.
Cool. I'm thinking if we should move to more societal topics, but I'm eager to take some more. I guess it is symbolic in some way. For one, okay, you can choose. I will list a number of topics now,
okay,
and you can pick one, unless you have something you want to.
No, I have a question, but maybe we should take it after work.
Okay. Whoa.
Okay.
And let's do that.
Models?
No. It's about multi or not.
Multi what?
Multimodal.
Should we go multimodal versus not?
Yeah.
Okay. But I add here as one of his choices. as well. So okay,
I was joking before you arrived.
That's one of my favorite topics.
Yeah, and I was joking. I bet you Anders is gonna put you on the wall, multimodal or not.
Clip,
so there was a joke, but we can.
We've already spoken about Clip. It's one of the most powerful multimodal models we have. Okay, so one potential question, and you can select one or multiple. But okay, one could be pros and cons with GPT-3, and a Swedish one.
Yes.
Another one could be, should we go more multimodal or not? I'm picking it from you because you said it. Yeah.
You liked it though.
Yes. Another could be the question of having large model and continuously scaling them versus usability.
Yes.
I guess it's connected to GPT-3. Another could be more neural networks, deep learning things versus symbolic AI. What is the useful way to go coming 5 years? Or should it be hybrid in some way?
Yes. Another
can be, how do we make the best use of AI? I would argue that AI is good at some stuff, humans are good at other stuff. What's the best way to have a benevolent use of AI? That's one topic.
We will be here all night.
No, you can't choose them all. You have to pick one, his favorite now. And let's see if we should add some more. Okay, so last one, then you can choose one. I can repeat them later if you want to. Another one could be that we saw a recent AI index report from Stanford, actually.
The high report?
What?
The high human AI?
No, it was called AI Index, and it's done every year, I think. But Stanford actually produced this report, and it's trying to look at the number of metrics on how AI is being used, and one of the metrics is the amount of private investments being done in AI and in US compared to China and EU. And the weird thing here, we've been speaking about AI divide a bit, and if you look at this graph, it was actually surprising to me when I saw this report, is that the amount of private investments in this AI index report is actually accelerating in US faster than it is in Europe. Yeah, perhaps you can see it.
Yeah, this is high. What's this? That human AI?
It should be the private investments graph if you can find it. It's a big report here, but
so it's not only on it's not only on a higher level, but it's also increasing faster.
It is. So
I'm sorry. It's not only on a higher level, but it's increasing faster. Yeah.
So if you think of the graph, I can just show with my hands. The US has always been on the top, but it's accelerating faster than EU and especially, and China is trying to catch up, but it should be some other private investments.
Here.
No, it should be like 3 lines in a graph. Go down. It's such a big report. It's hard to find. Go a bit further down.
A private investment in geography area.
And it's getting closer, but there it is. This is
one.
The one. You see here, it's insane. What US is accelerating their private investments compared to China and Europe, right?
Yeah. So just looking at the numbers, the European efforts in this area is 1/3 of what they have in China, and the Chinese efforts is 1.
Yeah, almost 10 times, right?
Yeah.
And it's accelerating, and this is really scary to me, actually. What's your okay? Let's start with this topic. What do you think about this?
It surprises me. Also, it surprises me as well. I would, my guess would be that the European countries would sort of have accelerated this over the last few years, at least.
Yeah, but they have accelerated, but the amount of acceleration is because it's a big acceleration.
Yeah, but it's not only the numbers; it's the aggressiveness of acceleration, which is nothing.
Yeah,
but EU going from 2020 to 2021, it's more than doubled, I think here.
Yeah,
but still, if you look at US, they went from like 26.7 to 52, so they doubled.
Yeah.
Also, but they also started from like 10 times higher starting point.
Yeah.
So if you look at this, it's insane, right?
Yeah.
Will not this cause an even increasing AI divide, you think?
Yes. I think it would be interesting, of course, to see what kind of businesses doing these investments in the US. Is it the larger companies?
Is it 5 companies that is
exactly
doing this?
Or is that a good guess? I would say.
I would say it's 5 companies behind that number.
I don't think it's like this.
But this is not true.
How do you know? You don't know.
Look at the numbers above. So you have Germany 4.4, France 3.9. That is already 8.3, and here it's 6.42. So this is not correct.
Well, you have to send a complaint to them.
So you see, 6.42 for the entire European Union. And only Germany and France have in total 8.3.
I think I have an explanation for that actually, because I think it depends. Would you count, for example, DeepMind as European or American? Because DeepMind is owned by Google, but it's placed in London.
Yeah, but it doesn't matter, because if you are statistically, if you're doing something like that, you cannot actually do it, because this is 149. So maybe there is something different that is here.
Yeah.
What are we looking at differently in those 2 graphs, by the way?
Yeah,
it's like 3 times higher for years. We shouldn't get stuck in this. We should.
But that's an interesting observation.
Yeah. But this was a big, I was surprised when I saw this, and it came out like a month ago or something. It's rather recent. Yeah. And it's from Stanford, your place.
Yeah.
You have to defend it. No.
Oh, no. It's kind of depressing. I don't know. It's really, really hard, if I look at the governmental sector, to use AI for good reasons and for bad reasons. And the bad reasons is, of course, that people higher up in the organization don't know this stuff. And then it's really hard to go from lab to production.
Exactly. That's an awesome point. I wish we had an hour more to speak about that. Okay, so let's do, you can only answer in 30 seconds now.
Oh, okay.
Like a lightning talk kind of thing.
So there was an explanation, I need to apologize. So this is basically accumulated from 2013 to 2022, 21. And this is basically, if you calculate everything, this is going to be accumulated, but this is per year. So this is 52 billion for this year.
For that
so the area under would be matching the...
Exactly. So this is true. So.
Okay. Stanford.
Okay, you couldn't. It would be fun if you found a bug in Stanford.
That would have been amazing. By the way.
Okay, so super quick reactions. What do you think about building a Swedish GPT-3? What are the pros and cons with that?
So when you talk to people who in the valley, in the Bay Area, where the big GPT-3 is behind the API, no one has really found a super useful case for this model.
Good point. Yes.
So that's a problem. On the other hand, as a researcher, we know that the big sort of benefit is usually the things that you don't think of.
Right. So you have to do some kind of basic research and then later see what the use will be.
Exactly. I mean, people come up with all kinds of weird stuff eventually. So I think the GPT-3 eventually probably will, someone will find something out to probably put it in another context, or someone will build another model upon that, so it will be a stepping stone or something like that.
And it's interesting that it can do so many different tasks.
Yeah.
So if you're interested in general in AI, then of course this is an interesting move. Right?
Drawbacks with the model is it's really, really big. I mean, the big GPT-3 is 75 billion parameters. So that's a model just to sort of to do normal inference on that. You have to have substantial computational resources to use it. That's a big problem. Another big problem is that it's the case for building a Swedish one, of course, is that then it would be sort of not behind the walls of a big company. It would be something, then there's the security issues, because if you want to produce fake news, etc., you always have the advantage of not having to fact check. So the model can just you can build your own newspaper factory. That is a problem with the model with this kind of capacity.
And it looks really good. The generated text looks like it's proper, at least from a grammar point of view, but not from a factual point of view.
Exactly. And this could be done in a number of ways. So, for example, it doesn't have to be straight out lies. It just could be repeat someone in a context like very many times.
Good.
So that's a problem.
Yes, pros and cons, but still questionable if it's worth spending so many millions and billions of dollars and crowns into.
It's questionable.
But isn't the simple argument here also that GPT-3, whether we like it or not, has captured our imagination, and it has captured the imagination of even the layman, so to speak. So then it's an easy sell. Oh, we need a Swedish GPT-3. So even if, as an expert, we would know you could probably do smarter things with your money than that. But now this is someone that has the money and has, could relate to that because it was capturing our imagination.
Yeah, and that's happening in Sweden right now. So there will be GP3s, plural, out there in different sizes. I'm pretty sure it's
in reality, if I'm cynical, it's because people who don't really are the real expert could relate to that because it became such a news hyped thing.
Yeah. And we will also see it in other countries, European countries, of course.
So the hype is ruling again.
The hype is ruling, but the hype is also sort of, it's not as hype. The hype is lower now, I would say.
You can start to find some proper use for it, but I think as long as they do list, this is the reason for why you should invest that much money for it, then I'm okay with it.
Give me a clear story. What's the clarity? What are you planning to use it for? That's a simple question, right?
But then again, from a research perspective, you could say that
we want to learn more about big models.
Yes, that's a fairly good STEM reason, but also that we don't really know, but we think that this is an infrastructure that will somehow yield results that are interesting down the line.
Because maybe that's the point, and we want to build this in order to better understand how infrastructure should look like for this.
In the library context, I can see a clear use. We could use it to describe our collections in different ways.
Right.
One very simple, as you said, we want to learn more about generated text and how to generate text, what we can do about that.
Let's take another small question. Not so small, but try to keep the answer small at least. So currently a very big debate on Twitter at least is between some of the more deep learning based people or neural network kind of people like John LeCun versus people that are more into symbolic AI like Gary Marcus, etc.
Yeah.
And I'm not sure if you have followed that at all or have you watched?
No, not really.
Yeah. But he, for example, argues that this is so hard to do briefly.
I'm thinking about my answer already, and the first thing I was, this answer is too long. Exactly. And I don't even know the question. Yeah.
But let's phrase it like this then. So you can very few people have a good definition of what symbolic AI really means.
Yes.
Does it mean the old traditional kind of formal logic that you use for reasoning in some way, the old type of expert system in the 1980s? Yeah. Is that what we're speaking about? Or is it like what Gary Marcus speaks more about, this kind of hybrid neural symbolic systems, like actually AlphaGo that he mentioned as an example, where they have a neural network or two of them, but then combined with Monte Carlo tree search, and he argues that tree search is a symbolic AI, hard-coded, rule-based thing added together with deep learning networks. And in that way it becomes a hybrid system, and he believes that is the proper way to do it in the future. Do you have any thoughts about this?
The real breakthrough when it comes to the transformation of how we do things wasn't model-driven at all. It was driven by hardware, basically, and data. And I think that's an interesting... There's a long answer.
Yes. It was a stupid question to bring up, I think.
I think it's interesting when you have when the paradigm shifts in a way. I think it's very often driven by a technical breakthrough. More than anything else, and then it just steamrolls everything you think you know before, And then afterwards, the steamroller has rolled away. Some of that will start to grow again, and some of it will not. And you just use the stuff that is still useful. So, for example, entities still useful, part of speech not so much, etc. So some of the more traditional, symbolic, formal stuff will prevail and prove useful in a future setting. Some of it will not.
And can it also be that we get more and more clear when it's useful and for what very particular purpose it has a good performance efficiency?
Yeah. Perhaps, yes.
Yeah. I think it's also a lot of pride connected to this.
Yeah, very much.
Right? Yeah. And they want to keep using the terms because they have said they believed in it in the past.
Hence the keyword at the lab, morphology. When people, then we know, okay, they adhere to the traditional paradigm.
What is the definition of morphology? Is just the history of the word, or?
I'm not sure. I didn't really. I used to know it sometime and then I forgot it. But that's a thing that when we first came out with a model, we got much of the sort of feedback was very traditional, formalistic sort of questions. Right. And we were sort of, it doesn't really matter. We bypassed that now.
Perhaps we should phrase it like Jan LeCun did. He was so upset, after all the discussions, so he wrote a short tweet saying, "Put up or shut up." Basically saying, if you show me that it works, put up. Yeah. If you can't, shut up.
Exactly. That's the sort of, that could be one of the many mottos of the lab as well, my lab. Yeah. Does it work or not?
Yeah. Perhaps one of the final questions here. If we speak about AI and humans in general, you can think about what is the most benevolent way to use AI, and you can think that potentially AI is good at some stuff and humans are good at some stuff, and potentially they're not the same.
Yeah.
And one saying, at least, that we are often using is that AI perhaps can go through huge amount of data, perhaps KB size data in some way, but a single human would never be able to do so.
Yeah.
But on the other hand, a human potentially could go through a small amount of data, potentially found or filtered out or enriched by AI, but do that in a much deeper way than AI ever could.
Yes.
Do you think that's a good way to phrase the differences, or how would you phrase AI versus humans?
First of all, I don't think really know. I mean, there's so many issues here. One is what is intelligence, etc., or understanding. I mean, that's an issue all the time. Do these models really understand anything? Yeah. And I'm sort of
leaning GPT-3 conscious as.
Yeah, exactly.
And you are leaning to.
That they really don't understand stuff. They have networks that are adjusted to some stuff, but doesn't really matter. Or on the other hand, you could argue that is understanding. That's exactly what happens in a human brain as well. Right. So then, what is the difference? But one thing that you sort of see when you work a lot with this is that some stuff that we thought were super complex, human stuff, weren't that complex at all.
Right. Right.
So it's not only that the algorithm can do fantastic stuff, also some of the human stuff weren't so complicated that we initially
made
thought.
It so you need to crack the code how to set it up, maybe.
Yeah,
or understand the
once we have large enough networks, we see, So I think, for example, the way we express ourselves is more limited than we thought initially when it comes to language. So it's easier for us to learn this than we thought.
There is a special name for this. I don't recall. It's something with Mologorfi's law or something. But it basically says that tasks that we think are difficult, like playing chess, it's actually hard for humans to do. Yeah. But it turns out to be simple for AI. Yeah. And things that are, hard for AI can be really simple for humans. Yes. At some point.
Yes. Like we take for granted to be able to walk or to see and all this.
Yes. Exactly.
Yeah, and I have a background in the Navy, and we had this signalist doing the Morse code. And when you have two Morse codes in the air simultaneously, a human could quite easily, with some training, distinguish them from each other. This was super hard for a computer to learn this.
I mean, I think we should recognize that AI, of course, is very different from humans to start with.
Yeah.
And also that AI is bad at some stuff.
Yeah.
But so are humans. Human can't even multiply large numbers or memorize stuff to any extent. It's horrible. Our memory capabilities is horrible in some way.
Yes.
Right?
I mean, there's the scale of things, but it's also this sort of persistence in, presented with the same data or problem, a human will make different conclusions or decisions, which is not desirable. So that's the thing. Also, one thing that they talk about when sort of regulating stuff, European style, there's a problem with transparency of these large AI models, yes, but there's a problem with transparency when it comes to human
exactly.
as well. For example, writing a lawyer writing why this person should be sentenced to this or that. We see the outcome, but we don't see the process at all.
No, that's a really good.
So a lot of the things that we sort of assume that humans are better at, humans are actually worse at. And the same goes for, there's a lot of talk of bias, for example, with AI models. That's true. It is a problem. It is an issue that should be sort of discussed seriously. But we have bigger problems when it comes to bias, when it comes with the sort of human decisions. And
very true. Awesome. We're a bit over time, but it's been worth it, I think. And we have so many more questions we could continue with, but I think we should try to wrap it up a bit and continue with the after work and take the real juicy questions then. But Love, what's next in your life? What's happening coming months? Professionally, privately?
Privately, yeah. So professionally, we will try to set up to keeping our own machines at least busy during the summer.
You started to plan for that already now?
Yeah. So what will you be crunching this summer?
It's a little bit of a secret.
Oof, that's an after work topic.
It will be discussed with other governmental agencies, etc. But it will be stuff that we can use it will be a little bit internally oriented for once, for our user needs and other governmental agencies as well. So that's for the summer. For the autumn, we are planning to use the pod in Luxembourg, Alexina.
And
so
it's on the podcast now. It's a computer pod.
Yeah, exactly. So to have a larger product there too, and then we're talking huge amount of data, huge neural networks. So it has to be sort of a very careful process deciding which model to actually build.
Yeah. And so you are right now pondering of what type of model you are wanting to go next for.
Yes.
And you have a short list of favorites.
Yes. But the thing is, the short lists are not long-lived. No. Because all of a sudden someone comes up with something.
I want to train a blip model.
Understood.
What's a blip model?
It's a version of clip.
Yep.
But it's really
cool.
But
that's a fantastic idea. I mean, we have so we started with sound, and all of a sudden we could do all these things with sound at the library. We have also the TV broadcasts.
This is the blip.
So I mean,
so
we want to do video models, and then again,
there's so many choices for sure.
Yeah, there's so many choices, and then again, I mean, the amount of data when it comes to video is just
Sounds like a Luxembourg problem.
That was actually very funny. Yeah, awesome, Henrik.
I was a little bit slow there, so I'm sort of understanding now.
Exactly. Love, anyone that you would recommend to come on this podcast? Someone that you would love to hear us interrogate here?
Oh, yes. Does it have to be a Swede? Or?
We prefer to have them here physically.
Yeah.
But if they can come to Sweden, then great.
Okay.
Dream big first and then go. Reach for the stars.
I'm trying to remember the sort of previous guest list here because you have.
It's like 70 of them, so it's kind of.
Yeah. Let me think a little bit. Talk about something else in 30 seconds.
Well, we will continue with the after work, and we will have discussions then, and trying to get Love to speak about what the plans are for the summer.
Yeah, we will definitely get that out of him, don't we? Yeah,
in some way or form.
Yeah.
It would be interesting, I think, to talk to someone who is a little bit of a decision maker, maybe in a governmental agency, who is doing perhaps a good job, but not a perfect job, trying to implement AI stuff.
Oh, any specific agency or something you are thinking of?
Like Skatteverket or?
Yeah,
they're doing some work. Trafikverket.
Yeah. So maybe not the person like me, but someone, perhaps one step further up in the organization.
Someone sponsoring that we should do something.
Yeah, I mean, it's a problem in the boards of the governmental agencies. I think that this kind of competence is not represented. That is a general problem.
I like it very much, but can you just elaborate a bit more? Why do you think perhaps not having a person that is, the level of technical understanding that you have, but in a higher or in a board position or something? What's the reasoning for having that person on, you think?
Yeah, I mean, the higher up you in the organization, the less you know about the
That's a good definition, I think. C-suite.
But you want to hear the decision maker's perspective of the stuff we're dealing with.
Because I know less than my data scientists do about training, and so it would be a more technical, informed conversations if you were to have them here. But I think it's in the boards you have the different domains of knowledge are represented. This is a huge new domain. It needs to be represented somehow.
I like it.
So.
That sounds like a great
idea. And it goes all the way back to the simple storyline that if you really want to do stuff well, you can't bring the scientist perspective in too late.
No.
And all of a sudden now it goes, you can extrapolate on that problem all the way up to the board.
Yes, I think so.
I think so too.
And it's just the sheer sort of time that we need to explain stuff, even when we have very sympathetic sort of supervisors. We don't really get anywhere.
But let's take it after work. But I mean, like there are so many facets of this problem. Another, you go to the board level. Okay, you have your 5 slides and 15 minutes.
Yeah, exactly.
And how do you deal with super complex topics?
Yeah.
You're dumbing it down until there's nothing left.
Yeah, and I also think that data science in general, not only artificial intelligence, but it's here to stay basically. So we need to have an understanding of that also in top management level.
Certainly agree. Love, it's been a true pleasure to have you here.
Same.
And looking forward to continue discussion. Hope you can stay on for some time at least. So thank you very much for coming to the podcast.
Thank you guys, it's been great.